All right, so before we left, what we had started on was graphs of sine. But we did not finish all of that, okay? So this is going to be like part 2 of the graphs of sine. So I'm going to, so we're not confused, because in my other class, I'll do all this in one day. So for those of you at home, you did graphs of sine all in one day, but 2 separate videos because I record in 50. So that's why it's called graphs of sine. And I'm not going to rewrite target. Same target as it was before. But I do want to just kind of review, that was a long time ago. Also, everybody, please make sure you're checking student portal. Make sure the grades that I've entered, I entered correctly. If you did something and I did not enter the grade, make sure you let me know those things, okay? Probably I'm not going to catch it on my own. You'll need to double check my work. Okay, so last time when we had to do graphs of sine, part 1, we learned that the parent function for graph of sine looked like the first example that we did. It started at 0, 0, and then it went up. It's just you're following the circle around and labeling the ordered pairs. So at 0, 0, the sign was 0. At pi halves, the sign is 1. At pi, the sign is 0. At 3 halves pi, the sign is -1. At 2 pi, the sign is 0, right? So that was the parent function. And then of course that can change depending on the problem. This is the most basic graph of sine. Y equals the sine of x, what it's going to look like. Your domain is -infinity to +infinity. Your range, well, the highest y value you have is +1 and the lowest is -1. And we generally do least to greatest. Remember the amplitude is how high above the midline and how low below the midline do we go. So we went 1 above the midline, 1 below the midline. So our amplitude is 1. And in the parent function, your period is 2 pi. That can change as well. Your amplitude can change, your period can change, the range can change. And we say that the sine function is odd because the graph is symmetric with respect to the origin. So remember, we can keep on going with this graph because this is just one cycle or one period. We can keep on going. Infinite numbers, infinite cycles or rotations to the right or counterclockwise, infinite rotations to the left or clockwise, right? This is just one cycle around the circle. Y'all remember that? And then we did a problem where our A changed to the number 2. Okay, so A tells us what our amplitude is. So what changed on this was our midline was still here at 0, but my graph went 2 units above the midline and 2 units below the midline. So your A value, that's the coefficient of the sine, is always going to be your amplitude, which that's going to affect your range. And then that is a vertical stretch by a factor of 2, which we wrote how to figure that out on a different page, the next page. So we should have written it before, but we did not. So if the absolute value of A is greater than 1, we say it's a vertical stretch by a factor of whatever absolute value of A is. If the absolute value of A is less than 1, we call it a vertical shrink by a factor of whatever the absolute value of A is. Okay? So example 3, we had y equals 1/2 times the sine of x. And this told us that they only wanted us to graph x between 0 and 2 pi. That could change. They could want 2 cycles and say like between 0 and 4 pi, or between -2 pi and +2 pi. Just sometimes they'll say it and sometimes they won't. And we did the math on that. Our graph amplitude was 1/2. Went 1/2 units above the midline and 1/2 units below the midline. Because absolute value of A was less than 1, we call it a vertical shrink by a factor of 1/2. Domain's always going to be -infinity to +infinity. And then the range is -1/2 to +1/2. All right, so that's where we left off. So let's do another one similar to what we've already done. We won't do anything new yet. I mean, I will be putting on some new things for us today, but let's do one like the last examples first. And we will call this example 4. We're going to graph y equals 3 times the sine of x. All right, and I always like to draw a little unit circle. It just helps me. Because sometimes when I visualize in my head, I don't get everything correct. And of course, you know, you want to get it correct. So what do? So we know the ordered pair here is 1, 0. We know the ordered pair at pi halves is 0, 1. We know the ordered pair at pi is negative 1, 0. The ordered pair at 3 halves pi is 0, negative 1. And then at 2 pi, it's 1, 0. Same as at 0. So we're going to make a table of values, and we're going to find the main points, our starting point, and then we're going to find a quarter of the way, half the way, 3/4 of the way, and then a full rotation around. Now that's going to change sometimes, okay? We're going to have this phase shift, it's called. But I'll show you how to spot when you have a phase shift, and it doesn't necessarily start in these places. But right now, those are the main points we're going to find. So I'm going to make me a little table of values. I'm going to go ahead and draw my graph too. What's my amplitude going to be on this one? 3. So I know my graph, I need to at least go up to +3 and then down to -3. We all good? Y'all need me to wait before I start on the table of values? We're good. Okay. So let's start when x is 0. So that means we're finding y equals 3 times the sine at 0. Well, what is the sine at 0? 0. So that would be y equals 3 times 0, because the sine of 0 is 0, right? And 3 times 0 is 0. So the first ordered pair is going to be at 0, 0. All right, pi halves. Y equals 3 times the sine at pi halves. What is the sine at pi halves? 1, right? Because remember, y is your, or sine is your y value. So that would be 3 times 1, which is 3. So at pi halves, we plot a point at +3. Let's do pi. Y equals 3 times the sine of pi. Sine of pi is, so that would be 3 times 0 equals 0. So at pi, we plot a point at 0. Three halves pi. Y equals 3 times sine at 3 halves pi. And the sine of 3 halves pi is -1. So 3 times -1 is -3. We already know what the last one's going to be. What's it going to be? 0, but let's do the math. Y equals 3 times the sine at 2 pi. 2 pi, the sine is 0. So 3 times 0 equals 0. So we're going to draw a smooth curve. So what is the period here? The length of one cycle, 2 pi. What is the amplitude? 3. Is it a vertical shrink or a stretch? Stretch by a factor of 3. What is the domain? Nope. What's the range? -3 to +3. And do I include -3 and +3? Yes. I'm not forgetting anything. I don't think so. All right, okay with that? All right, let's do one more that's similar. Will be example 5. And we're going to graph y equals -2 times the sine of x. So I already have my unit circle up here, so I don't need to draw it again. I like to have it on the page somewhere so I can refer back to it. Okay, so I already have my unit circle, so I'm not going to redraw that. I'm going to go ahead and make my table of values. And I'm going to go ahead and draw my graph. And what's the amplitude going to be? 2. So we just take the equation, and wherever we see an x, we substitute whatever we're finding the sine of. So we're going to start with finding y equals -2 times the sine of 0. And what is the sine of 0? So -2 times 0 is 0, which is what we figured. Do you think at pi halves we're going to plot a point at 1? like we normally do? Let's see. Y equals -2 times the sine at pi halves. What is the sine at pi halves? What's -2 times 1? -2. See how this time it's a reflection because a is a negative number. Because usually we start at 0, 0, and we go up to the highest point, right? But because a is a negative, it made us go down to the lowest point instead. So we'll find y equals -2 times the sine of pi. The sine of pi is, so -2 times 0 gives me 0. Now we'll find y equals -2 times the sine of 3/2 pi. And the sine of 3/2 pi is -1. So -2 times -1 gives me +2. So that was going to be the highest point on the graph. Where do you think 2 pi is going to land us? 0. Let me show my math. Y equals -2 times the sine of 2 pi. The sine of 2 pi is 0. So that's -2 times 0 is 0. So what's the period? 2 pi, it's the length of one cycle, right? What is your amplitude? 2. Remember, amplitude is the absolute value of A. So A is -2, but it's the absolute value of A. And would this be a vertical shrink or a stretch? Stretch by a factor of 2. What's my domain? Negative infinity to positive infinity, or all real numbers. And what's my range? -2 to +2. And those are included, so we use the bracket. Coolio? Any questions? That way. What do you mean? Oh, you're welcome. We good? Everybody? All right. Don't write example 6. We're going to write some words. All right, now let us graph functions of the form y equals a times the sine at bx, where b is the coefficient of x and b is greater than 0. So what's different here is we've added in a b. We started with just y equals sine of x. That's your parent function. And then we put that A in there. So A changed to amplitude, right? When you just have y equals sine of x, your amplitude's 1. If you have any other number, that's going to change the amplitude. Well, now we've added a coefficient in front of x, okay? And that's going to change the period. So the amplitude is still going to be the absolute value of A. That won't change. But the period will. The period will not be 2 pi anymore. We will have to find the period by dividing 2 pi by the value of b. So usually before this, b's been a 1. So 2 pi divided by 1 is 2 pi. So we haven't had to worry about it. It's always been 2 pi. But if x has a coefficient, and it's got to be a number greater than 0, okay, then it's going to change the period. So one cycle is not going to be 2 pi lengths long. It could be larger, it could be smaller, but it won't be exactly 2 pi. I'm going to put a little label here. All right, so let's give it a whirl. I believe this is example 6. Let us graph y equals 3 times the sine of 2x for values of x that are between 0 including 0 and 2 pi including 2 pi. So our cycle is not, or our period is not going to be 2 pi, okay? But they still want to see the graph from 0 to 2 pi. So that could include more than one cycle now, okay? If they didn't tell us to graph it for values of x between 0 and 2 pi, then we would have just graphed one cycle, whatever it was. But since they told us they want to see the graph from those values, it could be more than one cycle. All right, where we're just used to having one cycle from 0 to 2 pi. We could have more than one now because the period's going to change. Does that make sense? A little bit confusing. Okay, so we know that the 3 is our A and that 2 is considered the B, right? Because it's in the form y equals A times the sine of bx. So first of all, what's our amplitude? 3, because that's not going to change. But our period is going to change because now there is a number for b. It's not just a 1 anymore. So to figure it out, you always do 2 pi divided by b. So in this case, that's going to be 2 pi divided by 2, which is what? Pi. So we're going to have one complete cycle from 0 to pi. So how many cycles are we going to fit on our graph from 0 to 2 pi? 2 whole cycles, right? We'll do one cycle, and then we'll fit a whole nother one in there. Because one cycle now is just a pi. So since they want us to graph from 0 to 2 pi, we'll have one cycle from 0 to pi, and then I'll start over again, another cycle from pi to 2 pi. Does that make sense? Yes, kind of, maybe. Okay, so right now, I'm going to figure out, and I like to do my graph. I like to figure out, let me see what that first section is, and then I'll go from there, okay? So I know my amplitude's 3. And I know I've got to get all the way to 2 pi. But first of all, let me just figure out to pi, because 1 period is pi now. So I'm going to separate pi into 4 equal sections. So I always go to the midpoint and then split each of those halves into equal sections. I'm going to worry about that for now. Okay, well, I got to figure out what are those sections going to be. Well, what's this halfway point going to be? Halfway between 0 and pi is what? Pi halves. What is a quarter of the way between 0 and pi? Pi fourths. And then wouldn't this be 3/4 of the way? We separate into 4 equal sections. So that'd be 3 pi over 4. So we're going to have one whole cycle there. Well, while we're at it, let's just figure out our other numbers. So from pi to 2 pi, I'm going to separate that into 4 equal parts. I'll do the halfway mark and then the 1/4 marks. So that halfway point's not going to be pi halves, right? Pi halves was down here. So we have 1 whole pi and 1/4 of a pi. Wouldn't that be 1 1/4? Which is what as an improper fraction? Isn't that 5/4? So 5 pi over 4. 1 whole pi plus a half a pi is 1 1/2 pi, which we call 3 pi over 2. And then we've gone 1 whole pi plus 3/4. So 1 3/4 is what as an improper? 7/4 pi, right? So 7 pi over 4. So really all we have to do is figure out the points for that first cycle, and then it just repeats the pattern. So I don't have to do the math for all of those numbers. Let's do the math for one cycle, and then it's just going to repeat the same pattern over and over and over. Hardest part is just making sure that you have these little increments right. So we're going to start at 0, and then pi fourths, three-fourths pi, pi. Oh, we'll stop at pi. So that'll be one cycle. And you can do the math for all of them if you want to, it's just not necessary. All right, so let's start at 0. Y equals 3 times the sine of 2 times 0. So you're like, okay, well, that's different. What part do we do first? You do the 2 times 0 first, right? Because are you going to see 2 times 0 somewhere on your unit circle? No. Are you going to find the sign of 0 on your circle? Yes. So the order of operations, you would do the 2 times 0, the 2x first. Now, of course, I needed me a little unit circle. I forgot to draw that. You probably already have this memorized. All right, so what is the sign at 0? 0. And 3 times 0 is 0. So, as we suspected, we'll start at 0, 0. Let's do pi fourths. Y equals 3 times the sine of 2 times pi fourths. If you need to do the math on the side, that's okay. So 2 times pi fourths. Figure out what 2 times 1/4 is. 2 over 1 times 1 over 4. We multiply fractions straight across, right? So 2 times 1 is 2, 1 times 4 is 4, and that reduces to what? 1/2. So isn't that the same thing as pi over 2 if we would have put that pi in there? So that's y equals 3 times the sine of 1 pi over 2, or we just say pi over 2. Pi halves. Well, what's the sign of pi halves? 1. So that's going to be 3 times 1 is 3. So at pi fourths, we go to our highest point on the graph, which is 3. Let's do 3/4 pi. So y equals 3 times the sine of 2 times 3 pi over 4. Which 2, the same thing as 2 over 1 times 3/4. You can put the pi in there if you want to, if you're going to get confused. But so 2 times 3 is 6, 1 times 4 is 4, and that reduces to what? 3 over 2. 2 divides into 6 3 times, 2 divides into 4 twice. So 3/2 pi. Right, so 3/2 pi, the sign is -1. Wait, something's not right. Oh, that's what it is. Okay, oopsie. So my math is correct for this one. I was expecting to come down to 0, right? Because I should be at 0 at pi halves. But for those of you at home, they just told me that I forgot pi halves, which is the next one. So my math is right. It's not going to be here. It's going to be here. So I'll have to go back in and include that one. Okay, so the sine of 3/2 pi is -1. So 3 times -1 is -3. So be careful. At 3/4 pi, we're at -3. I forgot pi halves, so I'll just make this next one pi halves. Do a little arrow so I know, like, I won't confuse myself. And then I'll need to add a pi at the bottom. That's why I had extra space. Everybody okay with that? See what I did? But knowing what the graph of sine looks like, you knew, wait, something's not right. What did I do wrong, right? Just knowing what the graph is supposed to look like lets you know when you have an error. So let's do pi halves. Y equals 3 times the sine of 2 times pi halves. Think of that as 2 times 1/2 pi. So 2 over 1 times 1 over 2 is what? 2 over 2, which is 1, or we'll say 1 pi, right? So y equals 3 times the sine of pi. And what's the sine of pi? 0. So 3 times 0 is 0. So go back to pi halves and plot a point at 0. All right, and then we have pi. Y equals 3 times the sine of 2 times pi. Well, isn't 2 times pi just 2 pi? Right, so there's no fractions to simplify. So what's the sine of 2 pi? 0. So 3 times 0 gives me 0. So we fit one cycle between 0 and pi. We usually do one cycle between 0 and 2 pi. Well, that's when one period is 2 pi. But this time, our period was only pi. So if they did not say to graph it between 0 and 2 pi, we would just stick with the one period, okay? But since they wanted to see the graph, the whole graph, everything between 0 and 2 pi, then we had to extend it out to 2 pi. Does that make sense? Am I talking Greek here? Like, or you understand what I'm saying? So we can do the math for all of these points, but we know it will be the same pattern all the way to negative infinity, all the way to positive infinity. So if we're at pi, where would my next point be? At 3. So at 5/4 pi, we're going to go up to 3. Where's it going to be at 3/2 pi? 0. 7/4 pi? And 2 pi? 0. Now, I know a lot of you are like, I don't need to do all that math because I know what the graph's going to look like. If I know the amplitude and I can figure out the periods, I don't need to do all that math. But you do need to do the math because you need to know how to do these equations. If you just saw y equals 3 times the sine of 2 times 3/4 pi, and I didn't show you this, I just showed you the pattern of the graph, you would be like, where do I start? I don't know, like these numbers, I don't know what part to do first. You know what I'm saying? So knowing how to solve these equations with sine, cosine, tan, all that stuff is an important part of trig. So that's why we do the math every time. Coolio. Okay, so we already said the amplitude was 3, the period was pi. So how many periods do we see on our graph again? We see 2 periods. All right. So what's the domain? Negative infinity to positive infinity. What is the range? Negative 3 to positive 3, and negative 3 and positive 3 are both included, so we use the brackets on both ends. And are we a stretch, shrink, what? We're a vertical stretch by a factor of 3. Anybody have questions about that? So on this one period, we were graphing this point, this point, this point, this point, and this point. So this part of the graph is halfway around the circle. That's what this is here. And then we graph from here to here to here to here to here. So if I were to unwind this circle and put it on a graph, this is what the graph would look like. Okay? Usually one period we graph all the way around the circle, divide the whole circle into 4 pieces. But since our period, which is pi, we graphed 0 from pi, we sectioned that off into 4 pieces and showed what the graph looks like. All right. Example 7. Let us graph y equals 2 times the sine of 1/2 x. And it does not say between 0 when x is between 0 and 2 pi. So if it doesn't say, you just graph one cycle. Okay? So we see that we have a b there. So we know a is 2, and we know b is 1/2. So that means our period is not going to be 2 pi, right? So, okay, well, do we know what our amplitude is going to be? 2. And so to find period, it's usually 2 pi. If b is 1, then it's 2 pi. But b is not 1. So to find a period, you do 2 pi divided by b. So in this case, that's going to be 2 pi divided by 1/2. Well, do we know how to get rid of a complex fraction? Yeah, we do. I'm going to multiply the numerator and denominator by what? 2. So my numerator, there's nothing will cancel because it's not a fraction. What's 2 pi times 2? 4 pi. And 1/2 times 2 is 1. So 1 period is 4 pi. That's twice as long as the ones we've been doing, right? But it's just 1 period. So you'll take 4 pi and separate it into 4 equal sections, because 4 pi is the length of 1 complete cycle. You know what I'm saying? So let's figure out what that's going to be first, and then that'll help us figure out what our table is going to be. So our period, our amplitude is 2. I'm going to draw my line out. I'm not going to make it any longer just because of room. But I know it's going to go all the way to 4 pi. So I'm going to figure out what's half of that and then separate the 2 halves into halves. So it's 4 equal pieces. So my halfway mark is going to be what? 2 pi, because it's half of 4 pi, right? Well, what's this mark going to be? Pi. It's either 1/4 of 4 or it's half of 2. And what's this mark going to be? 3 pi. Because it's 3/4 of 4, which reduces to 3. So that's 1 cycle with a period of 4 pi. Y'all cool with that? Could you graph it right now without even doing the math? Of course you could, but that's not how we roll. We do the math. So I'm going to make my little Table of values. I'm going to start at 0, and then pi, 2 pi, 4 pi. So what we're doing is we're graphing one whole time around the circle. That's only 2 pi. So we've got to go a whole nother way around the circle to get to 4 pi. Okay, we're going to make 2 revolutions around the circle, and that's what we're going to see the graph of. Well, when we do the math, everything, once we multiply, everything will simplify to either pi halves pi, 3 halves pi, or 2 pi. But we could, right? I could make this 4 pi. This would be pi, 2 pi, 3 pi. I could do that, but when we multiply them two together and the fraction simplified, it'll be one of these numbers. What? Did it again. Yes, this would be 3 pi, 4 pi. Thank you for telling me now. All right, easy breezy. So we'll start at 0. Y equals 2 times the sine of 1/2 times 0. Well, what is 1/2 times 0? 0. So we have 2 times the sine of 0. And what is the sine at 0? 0. So we have 2 times 0 is 0. Just as we suspected. Now let's do pi. Y equals 2 times the sine of 1/2 times pi. Wasn't half a pi the same thing as pi halves? Right? So basically, that's 2 times the sine of, what is the sine at pi halves? 1. So I didn't mean to write sine. So I'll just rewrite this. I'll do pi over 2. 1/2 times pi, same time as pi halves. Didn't mean to confuse y'all. So we already said the sine of pi halves is 1. So that will be 2 times 1, which is 2. So when x is pi, y is 2. And then at 2 pi, we have y equals 2 times the sine of 1/2 times 2 pi. Well, what is 1/2 times 2 pi? Just pi, right? Because the 2's will reduce. So that leaves us with y equals 2 times the sine of pi. Sine of pi is 0. So y equals 2 times 0. Y equals 0. Let's do 3 pi. Y equals 2 times the sine of 1/2 times 3 pi. How am I going to write 1/2 times 3 pi? 3 halves pi, or 3 pi over 2, same difference. So what is the sine of 3 halves pi? -1. So we have 2 times -1, which is -2. We're solving trigonometric functions here. And we already know at 4 pi it's going to be 0, but we're going to do the math. So y equals 2 times the sine of 1/2 times 4 pi. Is it time to go? I'm going to finish this video. Y'all can go. You already know what it is. We have y equals 2 times the sine. Half of 4 pi is 2 pi. And the sine at 2 pi is 0. So 2 times 0 is 0. We already know the amplitude is 2. The period was 4 pi. Our domain is negative infinity, oops, sorry, to positive infinity. Range is from -2 to +2. They're both included. And this is a vertical stretch by a factor of 2. And I have one more thing to teach y'all tomorrow about this. And so we don't have any note or any assignment today, nothing for homework. So technically, I guess we'll have a part 3 on graphing sine tomorrow. So that is it. If there are no questions at home, you can log off as soon as you have these notes done. I will see you tomorrow. And I will post this video as soon as it is ready. Coolio.